Hi and welcome everybody. My name is Gernal Fernandez at Mertech Data, and today we're going to take a quick look at Flex2SQL version 11, which is the latest version of our DataFlex product line. So today we're going to talk about a couple of different issues. The first one we want to cover is using SQL as the master repository for your data, basically for your schema information, like where you design your database, where you make your table changes, not just where the data is actually stored. Then we'll move into talking about table casing. We'll cover a little bit about the changes we made to embedded SQL. Quick talk about the native SQL types, and then assorted goodies, other changes that we have made recently that we hope that you'll find interesting. So starting with SQL as a schema repository. Traditionally, all the data modeling has been done on the DataFlex side. You use the DB Builder. Now you can use the Studio. We can use Flex2SQL for creating tables, modifying tables, and so on. But there's also a multitude of database modeling tools out there that you might want to take advantage of that are on the SQL side. So our thinking was, okay, how can we make it easier for somebody if they want to use SQL to model their whole database? How do we get that quickly and safely back into DataFlex? And also, if you use the SQL as a schema repository, it makes it a lot more natural to then, define your relationships and constraints and so on directly on the server. So, let's take a look at a typical workflow on how this would look like. Okay, so this is the regular Flex2SQL migration tool that we have, the version 11 of it. So since I don't already have a database in SQL Server, I'm just going to go in and migrate the standard order entry sample. So come in here, now we convert it. I also want to make sure that all the relationships that I have on the DataFlex side gets created on the SQL Server side. So this is a new synchronized relationship dialog. So we'll tell you on one side it will list all the relationships that exist in DataFlex, and on the other side it will list all the relationships that exist on the SQL Server side. So here what we're seeing is that obviously we have the standard relationships in DataFlex, but the normal migration does not create the foreign key constraints, which is the way the SQL Server will enforce the relationship rules on the server. So now when I hit this button, it will synchronize all the relationship from the INT file into the SQL Server table. So we come in, I click this, you can see that the screen has now changed to reflect that the relationships also exist on the server. Now, if we start if we go into the SQL Server Management Studio tool and take a look, whoops, wrong server name. There we go. We can then see, like normal, we've migrated all the tables to the SQL Server backend. But now, since we've created all the relationship, we're able to actually use the built-in modeling tools that SQL Server Management Studio has. And there are also other modeling tools out there that we could use. For example, Visio has an option to create a data model for you, and there are tons and tons of other tools out there. So we'll come in, we'll create a new database diagram. I'll pick all the tables that I have. I'll add them. SQL Server will bring them in. And then it will clean up the layout a little bit. So in this case, we can see that we have the users and the orders table that have no relationships. It does display the primary key, but where it gets interesting is further down. We can actually see that the tool has graphically identified what our database model is. And we can see that the inventory key, inventory tables are related to order detail. It's one-to-many relationships from order details to inventory. Inventory is one-to-many to vendor. Order header is obviously related to pretty much everything. And then here you can actually drag and drop your tables around to get a data model that looks the way you want it to look. But the key takeaway here is that, without really much work at all, we have been able to get a full data model, a full view of our application, of our database. That's also a reason why you might want to use a modeling tool for designing your database, because you can actually work with it graphically, see all the connections, create fields, create new tables, which is just a new way, a more graphical way to working with your tables than working with the DB Builder or the Flex2SQL tool to create and restructure tables. So now I've decided that the SQL database is going to be my master repository for data. So say that I want to make some changes to the database. I'm not going to make the change on DataFlex side. I'm going to make them on the SQL side and then bring them back into DataFlex. So in this case, we'll just make a very, very simple change. Come into the inventory table, pick the sign, and I'll just add a new column. Of course, this could get very complicated. You could add tables, add indexes, pretty much do whatever you want to change to your database. But now we'll bring those back into DataFlex. So we'll come back here. We'll go to the tools option. We'll say generate INT from table viewer synonym. This option has been in our product line for a very long time, but we've completely reworked the workflow from this. Now it will list you everything in the database. So we'll select everything except this sys diagrams, which is something that was created by the modeling tool that we had. What we see here is that the tool has figured out that, okay, you're importing DBO.customer, but there already is a table in DataFlex called customer. So you probably don't want to import the customer table again so that you have two copies of the customer table. You want to import changes to this existing table. So in this case, it has picked up that say, hey, you want to reuse the table. It's already pre-selected the file number to overwrite the old customer table number. And there's also the green arrow here showing that this import will overwrite an existing table. So I marked all my tables in here. I could also, in this case, check the box to say import SQL relationships. In that case, it will do a complete import of everything that you have in SQL and put all the relationship information back into DataFlex. For this case, I won't pick that because we'll do that by hand later. But you could check this. Click OK, and you'll get a complete copy of the full database from SQL. All fields, all indexes, all relationships. So we'll go ahead and we'll import the new changes. Click OK. It will warn me that there's already an INT file in here that has relationship information, basically telling me that, hey, are you really sure that you want to do this because you didn't select to import relationships, so you might overwrite, you might lose relationship information on the DataFlex side. In this case, I think I know what I'm doing, so I'll say yes to all and import everything again. If you go in, do a browse data, we'll see now that that's a new column, column 1 that I created is properly on the DataFlex side. If we now select all the tables again, come back to the synchronized relationship dialog, we can see, aha, I said I don't want to import relationships. So everything, all the relationships in DataFlex are now missing, which, if we tried to run the order entry sample, it wouldn't work because DataFlex needs the relationship information. But in the SQL side, I have the relationships in there. So I come here, I say synchronize, and now it's put all the relationships back into the INT files, basically, so DataFlex knows about the relationship. I could have also done this by just checking the checkbox that we talked about a minute ago, but I wanted to show the full step. So basically, in this case, what I've done, I've taken a database from SQL that has relationships, indexes, fields, everything, and brought it all back into DataFlex. And with the new generate INT file dialog, it's a very simple step. You come into the dialog, check all your files, click OK. Any changes that you made on the SQL side are now over into DataFlex side. And this simplifies it a lot if you decide to use SQL as the main repository for where you make your schema changes. So now let's go back. Okay. So now let's talk a little bit about table casing. Table casing is probably the new feature that all of you will notice right away. Traditionally, we have uppercased everything, table names, field names, down to the index names and so on. Now we allow you to have full control over the casing. The new default that we have set up is to keep the casing. So whatever case you design your table to be in, it will be created in that case on the SQL Server side. This is, of course, a major change from previously, in that before, whatever the case was, it got created as uppercase on the SQL side. This affects the migration tool. Any migrations you do with Flex2SQL, be migrating new tables, restructuring, and so on. There's a new preference option in there that allows you to pick, if you want to keep the case, if you want to uppercase everything, or want to lowercase everything. If you restructure, if you write your own code to do restructuring, the new casing will have effect in there also. Same thing for a DB builder. One key thing to remember is that if you have an existing table, might have been migrated with an older version of our product, or even with the current version of our product, and you say, I want to migrate this table in lowercase, for example. If you then switch the casing to uppercase, any changes you make to that table, you add a new field. That new field will be uppercasing. So the previous case of the table is ignored, as whatever your current setting is will have effect everywhere. So how do you control this? You either, if you're in Flex2SQL, you can just go in the migration tool preferences. If you, for example, are in the DB builder, or if you write your own code, there's a new option in our Mertech.ini file that you can tell it what case you want to be the default. If you're writing your own restructuring code, there's a macro to set the global file casing, and there's also a file level attribute that you can use if you just want to have one file set to a particular case. So there are a couple of things to think about. Is that if you're using embedded SQL, Microsoft SQL Server is case insensitive in its identifiers, basically meaning it does not care if a table, if you refer to a table in uppercase or lowercase, or a field in uppercase or lowercase. It's fully case insensitive. Oracle, if you have unquoted identifiers, it's assumed to be all uppercase. If you quote them, it's assumed to have the exact case. MySQL and the table case are case sensitive, and in PostgreSQL, the case sensitive if quoted. So each database does it a little bit differently. So the key thing to think about here is that if you have embedded SQL in your code, and you're using Oracle, MySQL, or PostgreSQL, if the casing of your tables now change, some of your embedded SQL may now return a table not found or field not found. So that's something you definitely want to think about before you decide to switch to another case than from using uppercase beforehand. As far as the driver itself is concerned, it does not really know or care about the casing of the tables. You could mix uppercase, lowercase. The driver will still work, but this is specifically in context of your own embedded SQL. So the recommendations is that if this is a new migration, you don't have any embedded SQL, keep the casing. You had a good reason for picking the casing of the tables that you defined, and when you define them in DataFlex, so the SQL side should probably reflect that also. If you have an existing migration and do an upgrade, for example, you do some restructuring or something, probably want to stick with upper casing just so that new tables suddenly have a different casing, or new fields suddenly have a different casing. Again, from the driver perspective, it does not make a difference, but aesthetically looking, it might be odd if everything is uppercase except for a couple of new cases. If this is a new migration at a customer site and you have existing embedded SQL, test out your application, make sure that your embedded SQL works with the case. If the casing has changed, this is again especially for Oracle, MySQL, and PostgreSQL. Test it out and decide if you want to keep the casing or if you want to stick with the upper casing that you previously used. In all cases, we suggest you decide on one case and stick with it. And there's also a full chapter in our programmer's guide that deals with the casing issues. So next, let's talk a little bit about embedded SQL. We've done significant reworking of our Mertech.inc file, which is our include file that contains everything from custom macros to our embedded SQL engine. If you're using SQL fetch next row to fetch data into variables as opposed to binding into a record buffer, recompiling your application with the new Mertech.inc will see significant speed improvements with this. Because we've done a lot of work into how to handle the variables on the DataFlex side. Basically, the problem is that we have to pre-allocate the buffers in DataFlex space into the variables where the driver will then put in data. So we've optimized how these are sized, how they're filled up, and so on. So try it out, and you might be pleasantly surprised in the increased speed in your fetching records with embedded SQL. Overall, our rework of Mertech.inc, where we moved a lot of code from the actual macros into separate functions that the macros call, which will lead to smaller executables. So you recompile your application, you should see a reduction in size. We've also done a documentation revamp. We broke out the programmer's guide from the macro command and attributes guide, so that there are separate documentations. So if you just want to find out how the how particular macros work, or how what the syntax are of commands, there's a separate document in there that makes it a lot easier to search in. We've added a lot more examples, and also our full programmer's guide have gotten a lot more new content, but talking a little bit at a higher level about the different features. So Mertech.inc now has its own dedicated documentation. We've also actually gone ahead and implemented a completely new low-level API for accessing embedded SQL. And this does not go through macro commands or anything like that. We've actually created a new set of functions that you access through the regular DLL call mechanism. This new API makes it a little bit easier to handle multiple open statements. We've supported multiple statements for a long time, but you kind of had to switch in between them. This new API has a little bit more of an object-oriented feel to it, and that you get back a token for each open statement, and you refer to them via this token. This API is very straightforward, pretty easy to use. We had our plans for, maybe creating a new embedded SQL implementation, but we were not sure exactly what customers would want that our current embedded SQL option does not provide. So this allows you to roll your own embedded SQL implementation if you want to. Since it bypasses a bit more of Mertech.inc, there are some potential performance improvements there. And also, we would love to hear from you first if you want to know more about the embedded SQL API, but also if you have ideas for ways for us to improve our support of embedded SQL. If there's an interest in us creating any new classes or anything like that, we would love to hear your ideas. And now we have a new lower-level API that will make it a lot easier for us to implement this. So let us know, and we'll be happy to talk to you and happy to hear your ideas. Moving on to native SQL types. We have a lot of these types were already supported in version 10, but we've added extra supporting and extra testing for them. For example, in MS SQL, they've added a lot of date types, money, offsets, XML, and so on. One particular type to notice was the date type that was introduced by Microsoft in SQL Server 2008. This type mirrors the DataFlex date type very closely. It doesn't start at 7053, which we're all familiar with, but to customers it could sound like a little bit of an arbitrary start date, which was the limitation in Microsoft's date time data type. So the date actually starts at 0001. And since it doesn't have a time part, it makes it a little bit easier for using outside tools or anything like that there's not a time part for you to consider when looking at the date. It's just the date type. So we like this, and we suggest that if you have dates and using SQL Server 2008, migrate using this type because it has a very good fit with what the DataFlex date type is. If you're using date time, might consider moving to date time 2 because it also goes all the way back to 0001. The only thing to think about here is that, for example, if you're using Crystal or any other tools, the reports might have been created to expect the 7053 to be the 0 date. And in that case, of course, you can still use the old date time data type, and everything will still work. Oracle has we've added support and tests for a couple of more of the Oracle basically long data types, LOBS type data types that can have pretty much unlimited size. MySQL has a couple of interesting data types of Boolean type and enumeration type, where you can actually define up saying my variable can only take these three values, and I'm gonna refer to them by name. So you can have a color selection. You can have red, green, and blue. Of course, you could today create a character and mark it as R, G, or B, but then somebody could put in an X in there, and then through a mistake or through whatever, then what does the X mean? If you're using an enumeration, the MySQL will only allow you to put in values that you've defined up. And since they have an actual name in there, it makes sense to look in the database to say, oh, color selection is equal to red instead of color selection is equal to 1, 2, or 3, or RGB when it's and just having it defined as a character. And the set allows you to basically have a set multiple values and put them into one column, and then the MySQL will treat that. The set data is a little bit doesn't really have an exact fit with DataFlex, but we have support for that. You can bind it as a string and get it in and out. PostgreSQL support for the money type, support for the Boolean type, and this is actually a customer suggestion. They wanted to use UUID or the GUI data type, so we added support for that, reading and writing, and we bind it as a string. Again, a lot of these types were supported, but we've really exercised them a lot. Small int, tiny int, float, real, double, numerics of all types of sizes. The driver will also, during migration, pick an appropriate data type. So, for example, if you have in DataFlex, a decimal 2.2.0, that will actually fit in a tiny int, and a tiny int, storage-wise and performance-wise, is much easier for a SQL Server to work with than a numeric type, because a tiny int basically maps to a byte. So the tool will actually remap to these data types. You can also control it and say, no, I want it to remap, to always use the regular numeric types. And we also support more arcane data types. Especially Postgres has a ton of data types, geographic types, and so on. We bind as a string, and where possible, in some cases they're only read-only, but where possible they're read-write. And if you find a type that we don't bind to, let us know. We'll try it out, and if it's doable, we'll add support for it. So, our idea is you should be able to work with any database that you design or somebody else designed from DataFlex through our drivers. So we come to the last chapter, which are the assorted goodies that we had. One new feature, which is big, but it's one of my favorites actually. We allow you to now save multiple logins in the driver and the migration tool. Basically, it means that when you go into the login dialog, it will remember the last 5 servers that you've connected to. So if you're switching between a development and testing server, or testing and deployment and things like that, you don't have to retype the server name and the username and password, especially if they're different all the time. Now you can just drop down the server name, and it will have the last five servers in there. Makes it a lot more easier to work with multiple servers, and I really like this feature. Another feature that we've added is what we call a programmatic constant. This one is used if you want to consolidate multiple data folders. It's very common to have multiple full databases when you develop DataFlex applications. For example, you have company A in one database, company B in another database, company C in another database. So you end up with, in this case, you have 3 order tables, 3 inventory tables, and so on. What the programmatic constant allows you to do is to consolidate all of this into one order file in the SQL Server, one inventory file in the SQL Server, one order header file, order detail file, and so on. This works by inserting an additional company or folder ID field into your database. So for each table that is shared across multiple folders, you add a unique identifier. You have company ID, and you will put it in an A in the field if it came from company A, a B in the field if it came from company B, and so on. The driver, you tell the driver about your programmatic constant, and whenever you do an insert into a database, it will automatically use the current programmatic constant. And also all finds will be automatically constrained based on this. So the key point here is that it's only in your code, at the point in your code where you change the folder, that you need to add code. So, for example, in this case, assume that I've currently selected a current working folder. I switched companies. I popped up the company list, and a user selected the company name Acme. So, normally this would mean that you open and you change the current working folder and you start working against another file list. In this, you will still do that, but in this case, you would tell the driver saying that, for the salesperson file in this example, you would do this for the order file and any other files that you used to have multiple copies of, you will say that the programmatic default, of the first field, which I made the first field my company ID field, will be Acme. And I'll also set my constraint on this table to come from the programmatic default, and I enable it. So what this means is that from this point on, any finds you do against any of these, any finds you do against a salesperson table will not be constrained by Acme. So we'll only find records that pertain to that company. Same thing. If you do any updates or anything like that, the field value Acme will be automatically put into the company field. So you don't have to go through your code, and wherever you access this file, I gotta fill in the current company ID in my table, update all your index information, all of that. So you just use this code at the point where you're switching the current company, and everything else will work as previously. For doing the actual migration, the first migration when you move from DataFlex to SQL, what we recommend is that you go in to different data folders, restructure the table, the DAT files, to add this company ID field, insert a proper company ID field in each table. So now you will have, 3 order tables, and they'll have company Acme, company something else, company something else, and all the tables that you want to join together will now have these unique field values in them. Then you use our migration tool. You go into the first folder, you migrate the table, which will basically create a table on the SQL server and copy in all the data. For the following data folders, you won't migrate the table again. You'll open the data folder and then select copy data from that to table. So this will append the new information to the existing order table. So you'll now end up with one order table with all the orders from all the companies you had filled in by, and each line will have the proper company ID field value from where it came. You make this small code change at the point where your application selects the current data folder, and then you don't have to make any other changes. And your application will work as a fully consolidated database. And this makes it a lot easier for the future, if you want to do any reporting or any processes that span multiple companies. You don't have to jump in and out of data folders, all that. You can do all your coding against one big table. Another feature that is very interesting is we now allow you to get out the SQL script from restructuring. Normally, you do your restructuring on the table using our migration tool or using DB Builder, and what ends up happening is that the code gets committed to the server. If the tables are updated, you get your new INTs, you get your FTs, your new tag files. We've always allowed you to actually copy out the restructuring code that we were going to execute. But how do you get the changes onto the customer's database? Before, you would either have to make the changes yourself. You would have to take this restructuring code that we presented to you and execute at the customer side, but then you need a mechanism for doing that and so on. What we now allow you to do is when you do your restructuring, there's an extra tab in the restructuring dialog that you can actually see the exact SQL change that we will make on the server. So you can then make all your changes on your local development machine, your local test machine, deploy the application to the new customer, your new executable, your new INTs and FTs and so on, and then gather up all the SQL scripts that you get out from restructuring, and you can give them to the DBA or run them by yourself, and in that way bring the customer's database up to date. So you don't have to write your own restructuring tool or even go into a DB Builder or something at the customer site and try to recreate the changes you did yourself. Working with LOBS. LOBS are large objects. We allow we are able to store large amounts of data, practically near unlimited amounts of data in a column. You could use this for storing images, PDFs, scanned documents, and so on. So, if you have orders and there's a document associated with that, you can use our LOB functions to actually store that in the database together with the order, with the actual order data. This is as opposed to storing it in the file system, where if it's in the file system, yes, it's pretty easy to get to with, other tools, so you can browse to it and so on. But how do you do your backups, from the file system versus database storage? What if somebody's on a remote connection, they don't have access to a file share? They've only opened up access to the database. And also, it's a lot easier that documents get lost and so on. But now you can store anything in the database itself, exactly in the same row as the rest of the data is. So this is just a simple code example. In the first case, we've actually restructured the customer table to add a new field, 13 field that is a LOB tag column. So in this case, what we do is we clear out any old data from this field, and we say we want to. In this case, I have a document on file, and I want to load us into the database, and that's it. These 5 lines will take this, in this case, a PDF, and store it in the database for you. The second example first shows how you can get the total length of the data stored in the field, and then how it will, in chunks, actually read out the data for you, and in this case, write it back to a file. So these LOB commands makes it very easy for you to store data of virtually any size you want into the database. You can then read them out in chunks and store them to a file, or post them to a web server, or whatever it is that you're doing. We've also added a couple of additional scripting steps. We've always had that you could generate scripts for creating tables, scripts for using the Oracle or MySQL or PostgreSQL loaders, and so on. But there were a couple of steps that were missing. For example, in Oracle, there was no way to generate the scripts for adjusting the sequences, estimating the statistics, which is basically telling the Oracle to take a look at the indexing and maybe adjust that, rebalance its own indexes, and also update text columns after using the loader, which is a required step if you use the Oracle loader to fix up new line handling. MySQL, similar scenario. After you've used the loader, you need to restart the identity columns, Postgres, adjusting the sequences, and also estimating the statistics. The identity columns and adjusting the sequences are used for reclam handling. We also allow scripting for enabling and disabling triggers. So with these additional scripts, it allows you to basically script out every single step of a full migration. So, if you have an Oracle DBA that says, nothing touches my database without me looking at it first, you can, through Flex2SQL, generate the scripts for creating the tables and the indexes. You generate the loader files that will actually load up the data. He can look at the loader file, see what's going to do. He can look at the data, and then you can generate the scripts that should be run after the loader has done. You can then take all of this, give it to the DBA. He can look everything over, and then submit it to the server. So in this case, Flex2SQL does not need any write access to the database. And that was it. That's all for today. Thank you all for joining us and sitting through this presentation. And of course, if you ever have any questions regarding this or anything else that Mertech does, please feel free to contact us, via email, or our contact information is on our website. So thank you all very much.